This is 5-6C, and we're going to be solving for x in this equation. And the equation is 2x plus 15 is equal to 2x minus 15. Okay, so we have x on both sides, and we don't really want that. So let's try to zero out x on one side and see what happens. Okay, so a positive 2x plus a negative 2x will be equal to 0. And we have to do the same thing on both sides of the equation here. So once I've done that, I discovered that it's a positive 2x on both sides. So when I add the negative 2x, it zeroes out 2x on both sides of the equation. And what I have left on this side is 15 is equal to negative 15. So if I look at that, I know that is just not possible. 15 will never be equal to negative 15. So this actually is an equation that has no solution. There is no value of x that will make this equation true. All right, so now we'll look at D. And in this case, we're going to be solving for y. And it's 6x plus 2y is equal to 10. And because we're solving for y, we'd like to isolate y. And the first thing we'll do is zero out the 6x on this side. And we need to also subtract 6x from this side. So we zero out that, and we only have 2y left on the left-hand side. Over on the right-hand side, we have that original 10 minus the 6x that we tacked on or added on. All right, so now we need to isolate y, and it's being multiplied by 2. So to undo that, we will divide by 2. And then we need to divide each term on the other side by 2 also. All right, so 2 divided by 2 is actually equal to 1. 1 times y is simply y. And then 10 divided by 2 is 5. Negative 6 divided by 2 is negative 3. And we leave the x. Okay, so what we can also do is we notice this is very similar to the slope-intercept form. It's just we need to switch these two terms. And because of the commutative power of addition, we can move these terms. The order doesn't matter. We still get the same result. So there is our final result.